Welcome. My name is Tom Al. I'm a professor in the Department of Earth and Environmental Sciences at the University of Ottawa. Thanks for joining us today. I'll be talking about graduate research opportunities in our department, and I'm joined by Cole Fisher, who is a graduate student in our department as well. So Cole is going to help me out with communications. If you have any questions, then feel free to post those questions on the chat and Cole will pick them up and we'll answer them as we can. Okay, so I'm going to get started. I'm just going to share my screen here and pop up some slides. So, graduate research in the Department of Earth and Environmental Sciences. So I'm going to cover as much as I can. It's a fairly short time. I'm going to point you at the same time to the University of Ottawa Earth and Environmental Science website, because if you feel you need more details, certainly you can get those details there. And you can find the contact information for any of the faculty members and staff members in our department. So feel free to visit the website for additional information. Okay, so I'll just briefly introduce our department. It's a small department as our science departments go across Canada. We have 14 professors. I would say that we punch above our weight in the sense that we have a fairly strong research program and lots of research facilities to accomplish that. So 14 professors, one of those is a Canada Research Chair. We have excuse me, one distinguished university professor that's not included in the 14. As far as research-related funds go, we have the Goldcorp Research Chair, that's an economic geology chair. We have the Husky Research Fund, that's run by one of our professors, Bill Arnott, and it's petroleum geology-related sedimentology. And in terms of students, we have around 250 undergraduate students and about 80 graduate students. Those numbers fluctuate a little bit, but that's about where we are now. The programs that we offer at the graduate level, so MSc and PhD programs, there's 4 for master's specializations: earth sciences, chemical and environmental toxicology, environmental sustainability, and science, society, and policy. And at PhD level, we have the PhD in earth sciences, and then we also offer chemical and environmental toxicology at that level. A lot of our research facilities are pooled together in the Advanced Research Complex on campus. It's shown here. And really the flagship lab in that building is the Lalonde Accelerator Mass Spectrometry Lab. And that's a 3 megavolt mass spectrometer. I would say by far most of the analyses that are done are radiocarbon, but we have the capability and we do a large number of other radionuclides. So radionuclides as tracers in the environment and tracking contaminants, for example. So here we have a view. We're looking at the source, the ion source end of the instrument. The ions are released, going through some magnets, through a electron stripping process, and on through the flight tubes all the way to the detector. So this is a big lab, takes up a large portion of the first floor. And as you walk in the main foyer to the building, it's right there. So this is the only accelerator mass spectrometer in the country. So some other highlights of research facilities within the Advanced Research Complex, and also some of these are outside in different buildings. But we have the AMS facility, which I just described. There is a fairly new, well-equipped electron microprobe and scanning electron microscope. So from the point of view of electron beam imaging and analysis, we have that covered very well. We have a large and well-equipped light-stable isotope laboratory, one of the biggest in the country and certainly very well-known lab. We have Canada's most advanced noble gas isotope lab. We have a geochem lab that has really everything that you need for, say, lithogeochemical and aqueous geochemical measurements. That includes ICP-MS. We have a few ICP-MS instruments, one triple quad for, it's configured for solution measurements. And we have another one that is configured for laser ablation sources. And then we have the X-ray lab, and the X-ray lab has powder X-ray diffraction, single crystal X-ray diffraction, X-ray fluorescence, and we have a large, you would call it an industrial computed tomography instrument, but it's configured for radiography, tomography, and also spectrometry for chemical measurements. Just a few pictures here to show some of the instrumentation. This is the electron microprobe in the upper left here. This is a view on the upper right of the geochemical lab facility. The laser ablation system is in the back here. This is a ICP optical emission instrument and a microwave plasma instrument here. And this is down in the lower left, we have the triple quad that's configured for solution analysis. And again, here's the Accelerator mass spectrometer in the Lalonde lab. Okay, so I'm just going to quickly go through the research programs for most of our professors, and it'll give you an idea of what people do, but I certainly can't cover a lot of it. These are just examples. So if you need more information, I certainly encourage you to go to the website. Under each professor's individual site, you'll find more information, and more importantly, you'll find their contact information. So if you are interested in that type of research, then feel free to contact that professor and you'll get all the information you need. Okay. So going alphabetically, that starts with me, Tom Al. So I'm a geochemist, hydrogeologist, and I work on low temperature aqueous geochemical systems, contaminants in groundwater, solute transport, and most of that relates to waste management, either in the mining industry or in the radioactive waste management paradigm. So there's low temperature aqueous geochemistry, physical processes of transport by advection, diffusion, and also mineralogical research that is very important within that. Okay, the next one, Bill Arnott. So the name of each person, each professor is down on the bottom right here, just for your reference. So Bill Arnott is a sedimentologist. He is the one that runs the Husky Research Fund. And his interests are quite varied, but he spends a lot of time and a great deal of focus on density flows, submarine density flows, and the sedimentological features that are derived from those flows. And the field area that they work in with funding from the Husky Research Fund is in the Windermere Group in British Columbia. You can see a shot here in the upper right. And they've been working there for, I don't know how many years, well over probably 15, close to 15 years, I would think. And a tremendous number of students have worked there and gained experience and done some very good science. Okay, Pascal Audet is a geophysicist, and he is really working kind of looking at the relationships between earthquake seismology and large-scale tectonic processes. So here, just an example showing an array of seismic monitoring stations through the Western Cordillera, and taking signals from those seismic monitoring stations and processing them and relating them to crustal scale tectonic processes. Clément Bataille, geochemist, isotope geochemist primarily. And this is one example. He's using isotopes as geolocation tools. So he can track butterflies as they move across the continent based on the isotopic composition of strontium in their wings, for example. And taking isotopic measurement or samples and measuring isotopic compositions from a wide variety, whether it be wine or cheese or fish or whatever it might be, woolly mammoth tusks. Clément uses that information to tease out geolocation information. So the isotopic composition of those materials relate to the isotopic composition of the local geologic materials. So that's the link that he's making. Ian Clark, longstanding and well-known isotope hydrologist. Just an example of something Ian's working on here, the upper Ogilvy River catchment in the Yukon. And he's been working for quite some time up there looking at effects of climate change in the catchment. And this data on the right here showing hydrographs versus time for multiple years. He's kind of pulled those together and looking at this wavelet transform. He's looking at the periodicity of recharge through time as it relates to climate change. Okay, Mark Hannington, an economic geologist, works on mineral deposits and also very much involved in what I'll broadly call marine geology, but mapping of ocean floor geology. So this might be what you would consider Mark's field area, sitting on the deck of a boat and sometimes in sight of land and sometimes not, and sometimes in sight of the horizon and sometimes not, because here is Mark in the driver's seat of a submersible. Okay. Keiko Hattori is an economic geologist, and she's working on mineral deposits as well. This example here, she's focusing on volatiles in subduction zones, tracking volatiles as they're subducted from the near surface into the subduction zone and then recycled back up towards the surface through mantle or magmatic ascent processes, and looking at how those volatiles and the volatile compositions of the magmas affect and relate to the characteristics of mineral deposits. Glenn Mellon, another geophysicist in our department, is an Earth system modeler, and he works on issues like ice sheet dynamics. So I'm picturing Greenland here. So ice sheet dynamics as they relate to climate fluctuations is an interest that Glenn is involved with. He looks at crustal scale rheology of mantle materials. Those are the sorts of large scale processes that Glenn is really investigating with his modeling techniques. Jonathan O'Neill, he is a geochemist, but his specific interest is in Hadean, the very, very ancient history of the Earth. So 4.5 to 4 billion years ago, that's the realm that John investigates, the oldest rocks on Earth. So he uses petrology and geochemistry, isotope geochemistry, sometimes extinct isotope systems, to understand events that occurred in the early Earth history. Pia Pless, she's a new professor, relatively new professor in our group. And here I'm just showing she's been working on melt volatiles and volcanic materials. And these are images acquired with computed tomography to look at the three-dimensional distribution and fabrics of bubbles that entrap those volatiles in the magmas. David Schneider, our current departmental chair, he's I want to say structural geologist, but it's much more than that. Deformation of geologic materials at many different scales. So, at the scale of hundreds of kilometers, looking at, subduction zone type, compressional, extensional, transpressional, all these different environments, the deformation of the rock materials, that's what Dave's interested in. So everything from very large scale to the centimeter and millimeter and micrometer scale here. So all of that comes together into a more fuller understanding of these processes. And finally, Brett Walker is a Canada Research Chair. He's a geochemist, and his geochemical interests relate to dissolved organic matter and organic matter in general in the oceans. How old is it? How is it transported? How is it distributed? Those are the things that Brett works on, the cycling of that organic carbon. So transects are shown here across the South Atlantic and the Pacific and so on, looking at the distribution and the radiocarbon composition of that organic matter. Okay, so just to wrap up here, I don't want to just deal with the research opportunities. If you're in Ottawa and you find that you have some time and you can break away from your studies, there's a lot to do, and the recreation opportunities abound. Canadian Shield is close by, and it's wonderful in the summer, of course, but we have Gatineau Park on a nearby Canadian Shield, and the skiing, hiking, biking, it's all just wonderful. So, okay, I will stop here, and if we have any questions, we'd be happy to entertain them. No questions? Cole, just let me know you can hear me. You're there, right?
Yeah, I can hear you, Tom.
Yeah, okay.
I don't have any questions for you yet, but I'll think of some.
Okay. Okay, well, if there are no questions, what I'll say is thank you for joining us. And if you feel that you have some interest in graduate research in our department, then by all means, get in touch. The website is there. The links to individual professors are there. Contact people. The best way to consider and investigate opportunities is to talk directly to those people. So everybody's using Zoom now and Teams and all these other electronic media. It's so easy. If you're, it doesn't matter where you are in the world, we can link up and we can talk, and that can help you explore your interests. And there's also opportunities, you know, if you're really serious about the research opportunities here, you can, in many cases, find a way. There is funding within our graduate school in the science faculty. There is funding to assist with travel so that you can come and visit and actually see what the labs are like, meet the people, and you get a very much better feel for the institution if you do that. So, okay.